Hello, discrete math fans. We're going to talk about the biconditional now. So we spent a lot of time talking about the conditional. Now we want to talk about the biconditional. So given statement variables P and Q, the biconditional of P and Q is this sentence, P if and only if Q. And it's denoted with an arrow going both ways. And the only time that this is true is if P and Q have the same truth values. Either they're both true or they're both false. And P, if and only if Q, is false whenever P and Q have opposite truth values. You'll often see the words if and only if abbreviated as IFF. So when you see IFF, that's not a typo, that means if and only if. Let's write out a truth table for the biconditional. It should look like this. The only time that P if and only if Q gives you a true value is when the input variables are the same, either both true or both false. Now one thing that is not too difficult to prove is that P if and only if Q is logically equivalent to P implies Q and Q implies P. And once again, this is something that you should do for yourself. You should take the time to write out a truth table to prove that those things are logically equivalent. And finally, another way that you can write P if and only if Q is that you can say that P is a necessary and sufficient condition for Q. So now we have all of our logical connectives that we're going to be using. We have not, and, or, implies, and now an if and only if, our biconditional. Okay, that's all for now.